You are absolutely right, but I do want someone to remember what we call this. What are we doing right now when we write this out? What are we doing right now? Mark?
Factoring.
Very good. We are factoring, okay? So you have to factor it because in order to find the zeros, right, you need to use the zero product property, and you can't use that until you factor it. So, and then Jaden, what were the two factors you said? Negative 10 and positive 3. Now be careful, guys. Your zeros are not negative 10 and positive 3. Jaden, you have to rewrite it, right? Yeah. How'd you rewrite it?
F of x equals to x minus 10 and x plus 3.
Excellent. Then what did you do?
And then I should equal to 0.
Good. You plugged in 0 for f of x. So you got 0 equals x minus 10 and x plus 3. And then what'd you do?
And then if you calculate it, it would be positive 10 and negative 3.
X equals positive 10, and x is going to equal negative 3. So our zeros are negative 3 and positive 10. And remember, guys, this is called what form for a quadratic? What form is this? Anyone remember? Not vertex form. Vertex form is when the x plus or minus that number is squared. It's this intercept form, okay? And our p and our q values are going to be the same as the zeros. Cool beans? Any questions on the warm-up? Okay, today, one of the easier lessons in Chapter 8. And guys, this is the last lesson in Chapter 8, okay? So remember, after these last 3 lessons, we are having a quiz next week on 8.4, 8.5, and 8.6. Then we start review mode before our Chapter 8 test, which will include all of the lessons in Chapter 8, okay? 8.1 to 8.6, all right? Okay, so when we're choosing a function to model, so what we're going to be doing is we're going to be either given a set of points or a chart, and we're going to figure out, okay, is this a linear function, an exponential function, or a quadratic function? And we've learned about all of them, and I want you, just as a refresher, to write down what each of them are. So does anyone remember the equation for a linear function? Linear. Diana?
Y equals mx plus b.
Bingo. Y equals mx plus b. Do you remember the specific form that is?
Standard form?
It is kind of like standard form, yeah? Very good. We call that slope-intercept form. Awesome, okay? Now, a linear function, what does its graph look like? Eli? It's a line, okay? All right. Does anyone remember what the exponential function was? The exponential function. Diana?
Y equals b plus x, ab to the power of x.
Very good. Y equals a times b to the power of x, okay? Where x, which is our variable, is in the exponent, right? That's why it's called exponential. Do you guys remember that? Now, the exponential function, okay, there's not really a name for it in terms of what it looks like. Like, it's not a parabola, it's not a line, but I want you guys to just draw a curve that looks like this, okay? So it can look like that, or it can look like that, where it's getting exponentially greater or smaller as you move along your x-axis, okay? And then lastly, a quadratic function. Who remembers the equation and what the graph looks like? Sabrina? You wanted to say the linear one? Jaden, do you remember?
Is it y equals ax squared plus bx plus c?
Very good. Okay. So remember, a quadratic means that it has to have x squared in it. All right? And what did the graph look like? We just talked about all of these in the last, 6 lessons. Jaden? It's a parabola, okay? And it can either be facing up or it could be facing down. Okay? So these are our big 3. And these are the only 3 that we're going to be using in this lesson, okay? All right, so the first set of problems, it says plot the points and then tell me whether the points appear to represent linear, exponential, or quadratic. Do you guys have these steps on your page? Then write them down, okay? Step number 1, we're going to plot the points. Step number 2, we're just going to connect them with a curve or a line. And then step number 3, we're going to match them. Okay, is it a parabola? Is it a line? Or is it exponential? And then we're just going to write our response down. Yeah. No, I do not. Sorry, Layla. All right, let's jump into the first one. 4, 4, 2, 0, 0, 0, 1, negative 1/2, and negative 2, 4. Let's copy them down. 4, 4. I'm not going to ask for each one. You guys should know how to plot points, right? All right, 2, 0 should be right here. 0, 0 should be right here. All right, now let's talk about 1, negative 1/2. Where is that going to go? Sabrina? Excellent. 1 to the right of the origin, and then between 0 and negative 1. I want you guys to label that one because that one's super important to have in your notes. 1 comma negative 1/2, because I know we are not particularly fond of graphing fractions, okay? But we will have to graph fractions, and you don't have to be perfect with them, but you don't need to know which two numbers they lie in between, okay? That point that we just plotted is 1 comma negative 1/2. All right, and then our last one is negative 2 comma 4. Okay, so that was step number 1. We plotted all of our points. From your steps that you just wrote down, what was step number 2? Connect them, okay? So let's go ahead and connect these. And what is it going to look like? A parabola. So we say this function is quadratic. That's easy enough, right? Which of those points is my vertex? No.
Oh wait, was it the half?
It is the half one. Why?
Because it's like the 1 comma. Like I'm not saying it, but it's like the one you said.
It's what?
It's one in the center.
It's the one in the center. It lies on our axis of symmetry. It's the lowest point. However you want to describe it, but that is our vertex. Please label it. And let's move on to number 2. Number 2, let's plot those points. 0 comma 1 is going to be up here. 2 comma 4 is going to be up here. 4 comma 7 is going to be up here. Negative 2, negative 2. Negative 4, negative 5. All right, guys, someone give me their interpretation of what just happened. What does this one look like? Sabrina? It definitely looks linear. Why? Because it's a line. Do you guys see that? It's a straight line. So if it's a straight line, oh my goodness, what's going on? I don't know what a straight line. Rachel, you had a question? Why is the what? Yeah, I don't know. It sort of like got crooked on me. I'm sorry, guys, but trust your notability because your notability won't do that to you. All right.
You say that and then it doesn't.
Move on. We're going to do C and D, and then E and F, you guys, I'll leave those for you guys to do, okay? 0, 2, 2, 8, 1, 4, negative 1, positive 1, and negative 2, 1/2. Yeah, Jaden? The steps again? I'll go back at the end, okay? I want to get through this. So 0 comma 2, just remind me to go back at the end, okay, Jaden? 2 comma 8, 1 comma 4, negative 1, positive 1, and negative 2, 1/2. Notice negative 2, 1/2 is in between what two values in the y-axis? It's in between what two values in the y-axis? What? Nope. In the y-axis, guys. This point is in between what two values in the y-axis? 0 and 1. Do you guys see that? And it's because its point was negative 2, 1/2. So we have to go halfway up a unit, okay? All right, and so when we connect these, what does this look like?
Exponential.
It's exponential. That's it. No. Okay? The only other thing we're going to see in this lesson, guys, is we're going to see these in charts, and we're going to figure out what they are in charts. We've already done some of this before, right? All right, and then D. We've got -1, 5, -1, 5, 2, -1, 0, -1, 3, 5, and 1, -3. People, what does this look like? Parabola. And if it's a parabola, what kind of function is it? Thank you. It is a quadratic. Any questions on A, B, C, or D? Do we understand? At functions, right, in a chart. And I said if their difference is constant, it was linear. Do you guys remember when we were doing that? And we would say it was nonlinear if it wasn't constant. And then we looked at exponential, and they had a common ratio. In other words, they were multiplying by the same value. Okay, so I want you guys to just write a little note to yourself. Linear means that you are adding or subtracting by the same value. By a value. Exponential means that you are multiplying or dividing by a value. And that value was the same throughout the whole chart. A quadratic function is the new one. And that one is, you have to find what's called a second difference. So you would create your chart, right? And you'd be like, oh, they're adding 3 here. They're adding 5 here. They're adding 6 here. A quadratic function has a pattern in the second difference. So you're going to find what's the difference in what they're adding. So you're going to have 2 columns. And then you're going to see, okay, if that is a constant, then it's a quadratic function. It's hard to explain with words, okay? But once we see an example, you guys are going to get it, okay? Here are the steps for finding whether something is linear, exponential, or quadratic from a table. Copy these 2 steps down. Step number 1 is you check for a common difference or a common factor. That's the plus or minus, or the multiplication or division. And if it's neither one of those, then you are going to be asked to calculate the second difference to check if it's a quadratic function. Now, when these questions appear on a quiz or a test, I expect you to show me that you're calculating the difference, okay? I expect you to write either the common difference, the common ratio, or calculate all the way out to the second difference. That is going to be considered your explanation as to why you picked the answer that you did. So if there's no work shown about what the common difference or common ratio is, you're going to lose points, okay? Make sure you're doing these problems exactly how I'm going to do them on the board. These, and then we're done. Once we're done with this, we're done, okay? Tell whether each table of values represents linear, exponential, or a quadratic function, okay? Let's look at the first one. Is there a common difference happening here? Or is there a common factor happening here? Diana, what do you think? They're all going down by 3, okay? -3, -3, -3, -3. Now, there's one more thing that we need to check. Do you guys remember what the other thing we need to check was? The x values. They should also be consistent. Do you guys agree they're all going up by 1? Okay. When we have a common difference, right? We're subtracting 3. What kind of function is this? Eli? What's that? It is linear, okay? So we put linear and we're donezo, okay? Do you need to have these -3s down below? Yes, okay? That is what I'm looking for. That means that you understood that there's a common difference here, okay? All right, in B, we've got, let's make sure our x values are constant. What are they all going up by? 1, so put +1s, +1, +1, +1, +1. Now, what's going on in the y values? It's nonlinear, right? But is it exponential or quadratic? It's exponential. Why is it exponential? we're multiplying by 2. So when we multiply by a common factor, we say that this is exponential. Do you guys see the difference here? Okay, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Questions? We're Gucci? All right, let's see a quadratic function. Okay, so let's start with the x values. We're all going up by 1, right? Do you guys agree with that? Now, are the y values being multiplied by anything to move along the y values? I would say no, right? Because in order to go from -1 to 2, do you agree you'd have to multiply by -2? But then we should be alternating signs every time, and that's not happening, okay? So we know it's not exponential. So let's just go ahead and calculate. Let's see if it's linear or not. So how do you go from -1 to -2? -1. How do you go from -2 to +1? +1. How do you go from -1 to +2? You add 3. How do you go from 2 to 7? You add 5. Okay? Now, watch carefully. The second difference is finding what's the space between these differences. Okay? So, between -1 and +1, what's the difference there? We're adding what? 2. Between 1 and 3, what's the difference there? We're adding 2. Between 3 and 5, we're adding 2. This is what we call our second difference. Label it. Second difference. Guys, this is the first time we're seeing this, so if you have questions, ask. And if that second difference is a constant, right? It's all +2, we call this quadratic. Yeah. Correct. It's the difference of the difference. All right, once you're done copying this one down, I want you to look at D and tell me what you think D is. Eli, what do you think it is? It's exponential. Why? Very good. We are multiplying by 3 each time, and that's it. And we're adding 1. Okay, any last minute questions? Yeah.
Can you go back to
The steps, yes, I'll go back to the steps for the first